Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, let's continue our tutorials about HAB, hourly analysis program, to calculate cooling and heating loads. Here we go. In this video, I'm gonna show you how to complete the last two tabs in the zone. Open our mall. Here the weather, spaces, we have this office. Okay, we defined the general tab, internal loads, walls, windows, doors, roofs and skylights, and the last tutorial we defined the infiltration. Okay, now we are going to talk about the floors and partitions to calculate the heat, the amount of heat transfer from the floor and partitions. The partition is the inside walls that are not exposed to the sunlight, and the ceiling partition is not treated like the roofs. The roof also is exposed to the sunlight. Okay, here we go. Here the floor type, we have four kind of floors: floor above conditioned space, and here is our design. We assume that this is the ground level, and this is the first, and this is the part of the house lies on the ground. Okay, this the upper the lower surface is treated as the ceiling for this zone. Okay, and the upper surface, this is treated as a floor to this zone. Okay, now we are gonna talk about the floor of this zone. This zone, this is its floor. Okay, you can hide this object. Yes, this is our floor. This floor is above conditioned space or above unconditioned space. You have to decide if this zone will be conditioned or will not be conditioned. Okay, if this zone is conditioned, so the same temperature 24, assume that it will be 24, will be here and here, so there is no heat transfer from this zone to this zone. Okay, so there is no any further inputs you will set if this above conditioned space. Okay, so the amount of heat transfer is 0. And if your floor above unconditioned space, this zone will not be a conditioned space, the degree here, the temperature here, it will be 24 Celsius, and here it may be 35 or 38. So there is the amount of heat transfer will be transferred from this hot room to this cold room. So we have to take into the consideration this. Now what we gonna input is the floor area that is exposed to the hot part of the room. Why? HAP assumes that the floor area is the same floor area, 25 square meter, the full area, but this is not does not happen at many cases. You may have a part of the floor area only is exposed to the unconditioned space, like this. Here, if we isolate this, can hide objects, Look, this zone is divided by this partition, and you may make this part conditioned and this unconditioned. So you have to take the only unconditioned area, this only, not the full area, wide and length. No, it will be this from this to this, distance from this to this, and distance from this to this. This will be the unconditioned area, and the heat transfer will only occur from this part. Okay, if you do not have this partition, and the entire zone or this complete zone will be unconditioned, you have to take the full area. Okay, it will be 25 or 12.5, the half of the area, or whatever it is. And here are the total floor U value. You have to determine the heat transfer coefficient from the standards or from the civil or the architectural engineer. Here is the unconditioned space maximum temperature at the ambient, if the ambient temperature at maximum temperature. What does this mean? You have to input the unconditioned space maximum temperature. It may be 35. Okay, 35 at an ambient temperature of 42. This temperature will be exist if we have an ambient temperature, maximum temperature 42, the outside air at 42, and the unconditioned space maximum temperature will be predicted. This is a prediction. We actually do not know accurately, but it is set according to delta T between this and this, 10 degrees or 5 degrees, from 5 to 10 degrees, maybe 42 to, and here is 35. Okay, and this depends on the type of the insulation of the building and the materials and whatever. Okay, and so on. This for the cooling loads and the unconditioned space minimum temperature in the winter. If you have here, will, or sorry, if you are not sure about this temperature, you may set it as the ambient space maximum temperature, because it may increase to this limit or lower than it, whatever you want. For safety, cooling loads may be 42. And here in winter, unconditioned space minimum temperature that occurs if the ambient minimum temperature reach this value. And it is, you know that the inside air temperature is here is greater than the outside, and here it may be lower. Okay, notice this. Here in the summer, and here is the in the winter. So this may be 12.8 and this 23.9, and the difference is set to some kind of assumption is as 5 degrees. So you may make it 12 and here it's greater, will be 17 is greater than this, or also you may make it 12 like the outside ambient temperature, because we do not know it accurately. Okay, so we can make it for safety. Here is the floor above unconditioned space, and we are talking about this temperatures of this space that will affect the upper room. Okay, the third tab here, the slab floor on grade. Now we are talking about okay, in height objects. Now we're going to talk about the space on the ground. On the ground, this is the zone we're talking about here. You have to fill these tasks here. Only the floor area that you are dealing with, 25 if it is the full area length and the width, or you have to determine exactly what is the area of the slab floor on grade. Okay, and also the total floor U value, set it, and the exposed perimeter. Actually the perimeter here is not the perimeter of the rectangle. No, if this 8 meters and this is 4 meters, the exposed perimeter will be 8 plus 4, not 8 plus 4 and time and multiplied by 2. No, the exposed perimeter that deals with the exposed walls only. I do not care about the inside perimeter. If this wall or wall is inside wall, so the perimeter will be 0. I only deal with the walls that are exposed to the sunlight. So if this 8 meters and this 4 meters, it will be 8 plus 4 will be 12. It will be 12. Okay. And here the edge insulation R value of if you have an insulation, you have to put or set the R value of it like this picture. Right, this one. Okay, here the concrete floor slab, and this is the ground level, and here is the wall plate, and here is the ground. Yeah, and here, if you have an insulation to exterior face of falling, you have to put it set the R value, this and here the protective layer over insulation, and here sand blending and hard fill and under slab insulation. Okay, this insulation protects the zone from the outside cold air. Okay, this decreases the amount of heat transfer in winter. Here the air is cold, it's very cold, maybe 5 Celsius, and you have here 12 or above. So this insulation is greatly affect the heat transfer, and it is used only in the winter. So this kinda slab floor on grade deals with the heating loads only. Okay, so if you are concerned only with the cooling loads, you do not have to make it slab floor on grade because it will not affect the cooling loads. It will use only on the heating loads. And if you have this zone and it is on grade and you do not care about the heating loads and you only have to make it cooling load only, you have to make it floor above conditioned space because there is no any effect on the cooling load. Now the last kinda of floor is a slab floor but is below grade. I'm talking now about the basements. You may have basement like this and like this. The basement actually is lower the grade level. Okay, maybe this another basement. So how do we do? Here we have to put the floor area that is we are take it into consideration, maybe 25 or whatever. It is the floor area of the basement, and the exposed perimeter actually like what we said about this and plus this 8 meters plus 4 meters, not 8 plus 4 and multiplied by 2, no. Okay, maybe it is the basement is exposed to we have two three walls, so the distance will be from here to here added to the distance from here to here. Okay, this is the exposed perimeter, not the original perimeter of the rectangle. Okay, and here the total floor U value, can get it from the standards or from the person who are allowed to or is allowed to give it to you. And the floor depth, you have to set the floor depth. Now assume that this is the ground level, okay, and this is the basement. So the depth, it will be this height. That will be 3 meters because this height is 3 meters, and here is the floor of the basement, and here is the ground level. But this may be changed if the floor or the ground level is here, is from here. So you have to take into consideration the depth. The depth will be from this point and this point only, because you may have basement that half of the height is under the ground and the other is above the ground. Okay, so this the depth will be from here to here, or if this is the ground level, it will all the height. What if you have three levels under the ground? Like it may be you have designed that you have 2 levels under the ground. Assume that this is the ground level, and you have to make the depth or set the depth. You do not deal this case with the distance from here to the ground level. No, it will be too large. So what are we supposed to do? It is that if here the ground level and you have to deal with this only zone, you have to set the depth is the height of the zone only, not from here to the maximum point. No, it will be too large. It will affect the cooling load greatly. So here it will be 3 meters. Okay. For this is for the basement, the floor depth, and the basement you value. You may have walls for the basement, and this U value is different from the total floor U value. Okay. And you may also have a wall insulation R value for the basement. You have to put it or set it. The depth of the wall insulation, you may have here, assume that this is the basement, and you have, and here is the ground level, and you put insulation on the outside wall, but this insulation does not cover all the wall, so you have to put its distance from here to here, or whatever you want, or the insulation is from here to the maximum point will be 3 meters, as shown in this snapshot from HVAC Academy by engineer Sama Atif. Here is the finished grade. Okay, this is the foundation wall, and here the depth below the grade. Only we take this into consideration, and here's the floor of the basement. And here the wall insulation, we have, this is the wall of the basement, and you may have insulation depth. It may be from here to here, or from here to here, or you may do not have any insulation, so we'll make it 0. Okay. All these floors. So now you here you can make it 1 meter, 5. Please be careful when you input this data. Now we just have finished the floors tabs. Now next we are going to talk about the partition 1 and partition 2. Okay, now we're going to talk about the partitions. HAP software allows you to input two kind of partitions, ceiling partition and wall partition. Now here is the wall partition. What is the wall partition? The wall partition is the wall that is not exposed to the sunlight. Okay, denied objects, and here is our partition, and we assume that this partition, or we treat this wall as a partition if this zone is divided by 2, and you exactly know and you are sure of that this zone, suppose that these are 2 zones, okay, not 1 zone. These are 2 zones. This zone number 1, zone number 3, and here zone number 1, 2, 3. And you are sure of that this zone will not be conditioned, will not be air conditioned, okay? So this is partition. Here it is the inside wall, inside this object, inside object, yes, okay. So and this partition is not exposed to the sunlight, an internal wall, and you have to determine its area. The area is this length and this height, okay, or the full area of the heat transfer. The heat transfer equation is the area of the partition multiplied by the U of the partition by multiplied by the delta T between this conditioned space and this unconditioned space. Okay, if you have a door or window here, you have to take their areas into consideration, and the partition will contain the wall of the partition and doors or windows. You have to determine the area of the walls and the area of the doors, and you may take the average U for them. Here is the U value for the whole partition, and here is the area of the partition. Maybe 10 square meter, including the doors and windows. And the U value, you may have take the average of the wall and doors and windows. But actually, and this is a good thing, that the wall partition does not affect the cooling load greatly. So you may assume this use the average, or you do not have walls or doors. You can take the area as walls. Actually, we defined the walls here. Here are the partitions. So this is the U value of the partition, 1.186, and remember that the inside surface resistance is the same as the outside surface resistance, because this is an internal wall. It is different from the walls here, 0.12, and here is 0.05. Resistance is lower. Okay, so you can take this overview for the partition, and if you have doors, you may take its U and take the average. It is according to your senior engineer or your experience. So get back all doors and the partitions, but the area is the total area of the heat transfer. You have to take, if this area is the unconditioned and this conditioned, you have to take this area, and you can divide the area if your heat transfer area is lower than this. You decide this. The designer actually decide many things, and it doesn't matter if you decide something as an approximate value, no problem. We cannot make everything accurate. Okay. After this, as we talked in the floors about this here above, the unconditioned space maximum temperature. Here also unconditioned space maximum temperature, what will be 35 at the ambient temperature, maybe 42, or you can make it like what we did here, at maybe like 38.2. You can take it from here. If this 42 Celsius, you can take it as 42, but here is 38.2. This is the summer design bulb. So I have to say this for both floors. Here it is not 42. It depends on the design outside temperature. Outside design temperature 38.2. Here 38.2, and we said that you can take this 35 as an approximation or as an initial guess. So it's ambient at space maximum temperature. It is recommended to make it like the outside design summer bulb. Okay, no problem. Here the partitions set these values 0.2, and the unconditioned actually also here the weather properties. The winner in the winner design bulb is 7.8, and here the winter coincident with bulb. So you can take it 7.8. Here the unconditioned space minimum temperature, it may be 10 degrees, and here maybe lower than it will be 7.8. Like floors, yes, it may be 10 or 7.8. The ambient space minimum temperature is lower than the inside, okay, 10 7.2, the ambient space minimum temperature. Okay, that's it. And for the wall partition, here is the area. You have to make the set the area of the ceiling. The ceiling and this is the ceiling. This is the floor of this zone, and this is the ceiling. Here are the ceiling. The area of the ceiling actually, if this yes, there is something I have to say. If this is one zone, not two zones, you do not have to take this as a partition, okay? Because this the temperature here will be 24 Celsius and here is 24 Celsius, so there is no heat transfer, so there is no need to take this as a partition, and the partition area will be 0, okay? Because we treat it as single zone. Okay, suppose that there is no air partition. Okay, no problem. It will be already 0. For the ceiling, suppose that this is 1. Here we may delete this. And here the ceiling. The ceiling is the inside area, and it does not is not exposed to the sunlight like the roof. This is you can take the full area of the ceiling. It is actually it is the same as the area of the floor, but suppose that the upper zone is not like this. You may have it this the half of the area. So the half of the area of the ceiling or this part, the half of it is exposed to the sunlight, and the other half is under unconditioned space. If this zone will be unconditioned space, and half of the area you have the only half the area, you have to take it, you might be 5 square meter, and the other 5 square meter you have to define them in the roof, okay? Okay, this is the ceiling. Suppose that this zone is under a condition zone, so you do not have to define the ceiling, because there are no heat transfer from here to here, no, because the degrees will be the same, 24 Celsius, and here is 24 Celsius, but this is unconditioned space and unconditioned space, and the heat transfer will occur from the hot place to the cold place. So please determine only the area of the heat transfer according to the equation. Q equal the area of the ceiling of the heat transfer. Maybe from here to here only, doesn't matter, you decide this. And you may treat the other area as a roof if this wall does not exist, and this area is exposed to the sunlight. Okay. Here, actually, you have to set the U value, and the U value of the ceiling and floors are not too, they may be 1.1, and you have to get them from the walls here. Library, you may, the roofs, yes, we have here ceiling. This is 0.657, so it is low. Very low. So it will be 1.68 or here 1.6. Please take the values that we calculated from here. Here are the walls, the partitions is 1.186. Okay, and the roofs have ceiling 657. So the partitions and the wall partition and ceiling partition do not affect the cooling load greatly. And as we know, here 38, here 35, and here is 38.2, and here is 10, or you may assume another values according to your experience. Okay, here for the winter and here for the summer. Okay, and you may take it like 38.2 and 38.2. Okay, so gentlemen, we have just finished the all tabs of the space properties. But the question is now, when can we take this wall as partition? Actually, you can take it as a partition if you treat this as two zones. Both have two thermostats, and you are not sure that this will be the condition, the air conditioning device is running during the running of this zone. So you may take into consideration the heat transfer from the hot space to the cold space. So there are two zones with two thermostats. If you treat this place as one zone and you have this wall, you do not have to take it as partition, because the degrees will be the same, 24 Celsius, 24 Celsius, there is no heat transfer, so the area will be 0. As the same as this, the ceiling, if you treat this place and this place as one zone, or you treat or you take into consideration that the degree will be 24 Celsius and here 24 Celsius, there is no need to take into consideration the heat transfer from the floor and the heat transfer from the ceiling, because there will no heat transfer. Okay, heat transfer only takes place if there is a difference in the temperatures. Okay. Actually, you may deal with this zone as CAV, constant air volume, and or whatever VAV, variable air volume. You have to be sure that if this zone will not be at the same temperature of this, you have to take this area of the partition. Okay. If this it will be 35, 42, and this 24, take this partition. Like the hospitals actually the air conditioning system is running 24 hours, and all the zones are at the same temperature, or 24, 23, 22. So the heat transfer will not be great. So you do not have to take every inside wall as a partition. This will decrease the cooling load greatly and will decrease the cost. But another recommendation that, or another viewpoint that you are not sure of that the air conditioning system and all zones will be running at the same time. So you have to take into consideration the inside walls as the partitions. So there is a recommendation to be comfortable with these complicated cases or complex systems. You may take, if you are not sure of the both zones, or every zone will be at the same temperature at the same time, you may take the half of the area of the wall as a partition. Okay, do not take the full area, and you take the ceiling area only, and do not take into consideration the floor area. This takes into consideration the safety factor, and actually it reduces the cost. So you have to take the 50% of the areas of the internal walls. You may take the half of the area of this wall and take only the heat transfer from the floor or the ceiling, one of them. So this will work in a good way. But if you are not sure of this method, it is just a recommendation, and if you have another viewpoint that this place is far away from the middle of the middle of the town, and there is no, this is the touristic area, and people enters this room, and this room does not run as a conditioned space. You have to take the full area. Okay. Okay, we have talked about this problems, and you can deal it with the other engineers, and to see what are the recommendations, and to know what is the good decision. Actually, your decision depends on the design. Every design has its own circumstances and its problems and its running hours. So please, you have to be sure of your decision to make an excellent design. Okay, click OK. And now we're going to talk about another thing. Is right click and you can make duplicate for this zone. The zone will be copied, and you here office, no, maybe here maybe maybe a car station. Will be car stations. Station in 001. This is will be number 2 in the ground floor guard station. You may change the area and the average ceiling maybe 3 meter. Okay, actually I remembered that the area here of the this partition of this wall here, if you have a suspended ceiling, this is a good question. If you have a suspended ceiling from here to here, the partition, the area of the partition, it will be only from the ground or from the floor to this point. Do not take all the area from the 3 meters. The height will not be 3 meters. No, it will be from here to the tip of the suspended ceiling. It's a very good notice. I remembered it. I've just remembered it. Okay, here the guard station, the 3 meters and building weight if the same construction, and here the guard. You can choose the standard from here to determine the ventilation requirements, or you can make it as user defined to input the newest numbers from the newest standards 2013. If you choose from here, it will depend on the standard you use. Standard ASHRAE standard 62.1 2007. And here the project or properties, preferences, metric 2007. No, yeah, it will be 2007. If you use HAP 4.9, it will be up to 2010. But I recommend that you use the standards of 2000. Here is according to user defined and according to your input data from 2013 standard, and as we did before. The internal walls, you may change many things here according to the new place. And here the walls, windows, doors define this new zone. This zone is different from this zone for the orientation, for the outside walls. Okay, and all the roofs, skylights, the same. Change whatever you want to change. And the infiltration depends only on the circumstances that we talked about, and you may change it or not. The change will not be great. And here the floors determine the floor type and the partitions, and the temperature differences or this it does not change, so we can leave it but you may change the area and the u if there is another u value, and the partitions. So click OK. So you have now two spaces. Actually, you may duplicate this or duplicate this. You may duplicate this, and this is the third zone in the ground floor. It will not be guard station, maybe office space, common corridor, mall, common area, or maybe a pet shop. Pet shop. And please be sure of every detail and made user defined, and change this according to the standard. Okay, and the internals, change whatever what do you want to change, and the walls, the orientation of the walls will change, will be changed, and the roofs, infiltration, floors, and partitions. So click OK. Now we can right click. You can print input data or view input data. Click on view input data. Here you have the mall and the date and the time. Here the serial number and the ground floor office, and the general details, every details you have input, and the ventilation requirements, internals, internal loads here. Yes, windows and quantities and the construction types. Every thing you have input is here, and roof skylights. It's a full report. It's very useful. And second partition details, ceiling partition. In here the partitions. First partition details. Okay. Here partition. Yeah, because here is the 0. Okay. And partitions here will be 10. Here it will be 10. So there is a question here, a very important question. What if we have over 100 zones and we forgot to fill the this tab, the area tab? We set it to 0, and we forgot to take into the area into consideration. We will lose our time and our effort if we open every zone and change it. Okay, so there is another right click. So click on replace. It's very useful if you wanna change a number for every zone. You have over 100 zones and you forget to enter something. So go to the tab you wanna enter or change. Here the partitions, the unconditioned space, ambient space. Here, these are the partitions. There's a new value and unconditioned space. Here the ambient space or unconditioned space. You click here. We want to make this 0. Click replace. partitions. Here we can find only the partition U value, unconditioned space, maximum temperature, ambient space. So you have to be sure of the area that you input the area, because the area is not here because in many cases the area of the partitions will not be the same for every zone. Okay. Okay, here if you wanna change the average ceiling height or the requirements here for ventilation, liter per second or whatever, or internals here, if you wanna make all the task lighting watt square meter in a specific value, here a specific value to replace, leave blank to replace all values. If we want to make it 10 for every part zone, okay, 10, here replace with value. Okay, you select 3 spaces, 3 task lighting values were replaced. Click OK and open this. We will see that task lighting 10 and 10 and 10. It's very useful if you forgot to set these values, or you or have already set them, but you changed your mind and you have to make all of them with a single number. One number is 10 square 10 watt per square meter. You can make duplicate, replace here. If we make this 10, now it will be 8, and you have to replace only the 8 specific value to replace 8. Change the 8 only, replace it with 15. Okay, 3 spaces, 0 average. I'm sorry, it's not the average ceiling. Replace the internals and task lighting 8 with 15. It will be, the 8 value will be changed. So if you have 10 and 10, they will be the same. Okay, 1 task lighting values were replaced. This is good properties. Here 8. Here now it is 15, and the others it's the same 10. Okay, because you can do this if you change your mind in the future. If you change your mind in the future and you have to make these modifications. Here leave floor, no, partition 12 10, and here may be 6. Okay, this is the report. View input data here. Okay, on first partition details, and second partition details, ceiling partition. Yes. Here the first partition details 10 square meter, and the second partition ceiling, and here ceiling nodes. We have problem. Please be sure of what we use. Oh, this wall maybe 15, and here wall 10, and here wall. Okay. view input data. So here you can see the wall partition and the ceiling partition for the first, and here the second zone, ground floor, guard station. This is all the data, and the third zone, pet shop. Okay, you can save it, save report as RTF, and open it with Word software, and you can print this report. Now we're going to talk about the last thing is rotate. What does rotate do? Rotate, if you finish your calculations and the architectural engineer or the civil engineer told you that the north or the orientations of this campus, the north is not the north. No, the north the direction is wrong. So you have to change every orientation of the walls, of the outside walls. Okay, and the angled or the tilted roofs. It's very difficult, and it will lose your time and will consume your efforts. Will consume your energy, and you have to save your energy for useful things. So what should we do? This is not the north. No, this is not the north, and you have to rotate this building. Ask yourself, what is the north after the rotation? If you rotate this building, here is the north, okay? This is the north, east, south, west. If you rotate this 90 degrees counterclockwise, okay, the north will be what? The north will be here, okay, and the west will be here. So the north becomes west. So this is what we have. We wanna input here. This is the north, and this is the old north. After rotating this building 90 degrees clockwise, the new north will be here, okay, and the west will be, so the north becomes west. So you have to make this, drag it to 270 degrees, because the north becomes west. And if you rotate this counterclockwise 90 degrees, the new north will be here, and the east will be here. So the new north becomes here, and it was replaced by the east. So you have to make this, okay, 90 degrees. Okay, click OK. Rotating, perform it on 18 wall exposures and 12 roof exposures. And if you open this, you will this is changed, and everything was changed automatically, and you do not have to input this data. Okay. Okay, ladies and gentlemen, this is my last tutorial about spaces. I hope it is useful, and thank you very much. Please keep going and focus in your job. Do not care about the useless things. focus on your own business and try to learn by yourself HVAC and CFD techniques. Try to learn everything, try to learn languages to keep touch with many people all over the world. I'm trying to be a native American speaker and a native German speaker, and I'm trying to learn Russian. It is very important to me to learn it, because many tutorials of the CFD is in Russian, especially the turbo machines. Okay, and here is save the current project, successfully saved, and the future tutorials will be, if Allah wishes, inshallah, about the systems. Thank you very much, and have a nice time.